Today, we're going to talk about rotational motion. Rotational motion is when an object spins or turns around a fixed axis. The key points of the rotational motion is number 1, axis of rotation. It is the line around which the object rotates. Number 2, angular displacement. It refers to how much the object has rotated, and it is measured in degrees or radians. Number 3 is angular velocity. It refers to how fast it rotates, or how much angle it covers per second. Number 4 is angular acceleration, or how quickly the rotation speed changes. So, the examples of this will be a ceiling fan spinning, a Ferris wheel turning, and the wheels of a car when it moves. So to show you a visual representation of rotational motion, here is our ceiling fan. So as you can see, it is going on a circular motion around the center.
Since Yun is already discussed what is rotational motion, now I am here to show you the examples of rotational motion and demonstrate how they are calculated.
So here's the first example. A bead starts from the rest and it rotates to the random angle, which is it assumes to be 150 degrees with estimated time 15 seconds and experiencing constant acceleration. What is the angular acceleration and the final angular velocity? So, ang unang gagawin natin is right interest, which is ito sila, no? Para hindi tayo makalibog. So, ang gamitin natin na formula doon sa equation of kinematics, which is ito ang gamitin natin. So, isulat natin. Bika, plus 1 half times alpha, and then times square. So, ang una natin gagawin is hanapin muna natin si angular acceleration. So, ang mangyari dito is isulat tayong initial. Ito, sila dalawa. Initial is lang. So, cancel out lang natin. Tapos, dito na lang natin. Si 1 half times alpha. Acceleration ito si alpha. To be clarify lang. Tapos, times square. Tapos, ang iskalo, ilipat natin sa drawing sa kanila. Tapos, i-divide both sides siya. Para matira na lang kay si 2 theta divided by time squared is equals to alpha, which is si angular acceleration. Yan na yung gagamitin natin na equation para hanapin si angular acceleration. Simula na yon, ito na gamitin natin na equation. So, sige, ganito na yan siya. Ngayon, i-substitute natin. Si 2 times kay 150 degree. Pero, according sa rule ng rotational motion, dapat naka-convert talaga siya from degree to radian. So, ang mangyari is si pi radian divided by 180 degree. Tapos sa baba, yung time, which is 15 seconds. So, isolve na natin. So, first is 2 times 150 degrees times pi divided by kay 180 degrees. Then, ang baba niya, over, divided by 15 seconds squared. So, ayan, yun yung answer kay si 0.023. I-short na lang natin para madali. So, mangyari, ang answer niya kay si 0.023 radian per second. So, yan na ang answer sa angular acceleration. Ngayon, ang next na naman natin hanapin, or very last natin hanapin is si final angular velocity. So, isabay na natin sila, tayo malibog. So, missing si final angular velocity. So, ang gamitin natin ang kanyang formula sa equation of kinematics kay si ito na formula. Lagyan natin. rest man ang mention sa problem, then cancel out na yan siya. So, natira na lang kayo si alpha times 9. Ayan. Ayan, i-substitute na natin sila. So, nakuha natin kanina na angular acceleration kundi si 0.023 radian per seconds times by 15 seconds. Ayan, i-solve na natin. Si 0.023 rad per second times by 15 seconds. So, yan yung sagot kasi 0.345 tapos yung unit niya since 2 second then tingnan mo si parang i-cancel out. Ang mangyari sa unit ay radian per second lang. So, yan na ang final angular velocity. So, ayun. Yun ang answer sa kanilang dalawa. So, to be clarify, this formula dyan, kaya yung equation of kinematics is, ginagamit lang yan siya, depende sa problem. Like, ito, yung example 1 dimension ko, yung si angular acceleration. Then, si angular acceleration ang hanapin, yung naka-alpha na symbol. Kapag hanapin si final angular velocity, then, gamitin din ito. Ito siya. Depende sa flow sa isa ka problem. So, I hope na gets nyo. A little bit challenging, pero kapag times 2 mo siya read again, study again, analyze again, unti-unti nyo ito mag-gets yung problem. So, thank you for listening to me. I hope ma-apply nyo dito sa real life din.
Good day everyone, today we'll be talking about fluid mechanics, the branch of physics that studies how fluids, liquids, and gases move and behave. But first, what is a fluid? A fluid is any substance that can flow. This includes water, air, oil, and even lava. So fluid mechanics helps us understand how fluids act under different conditions. It has two main branches. The first one is the fluid statics, the study of fluids at rest, and the fluid dynamics, the study of fluids in motion. This science is everywhere, in engineering, medicine, weather forecasting, and even in our everyday lives. So let's start with a simple experiment about fluid pressure. An example of this is when I fill this bottle with water, we notice that how the water flows out faster from the bottom hole than the top one. So this happens because pressure increases with depth. In fluids, pressure equals the force applied per unit area, and it depends on the fluid's density, gravity, and depth. So the equation is P is equals to PGH, where P is the pressure, the letter P but a little bit slant is what we call density, the G for gravity, and H for height or depth. Now let's talk about buoyancy. An example of this is when I drop an egg into plain water, it sinks, but when I drop it into salt water, it floats. That's because the density of the salt water is higher, producing a greater buoyant force that pushes the egg upward. So this principle is also known as Archimedes' principle, and it explains how ships, floats, and submarines dive. Now let's talk about Bernoulli's principle in action. So an example of this is when I blow air over this sheet of paper, it lifts up. So like this. So that's because the air moving faster over the top creates lower pressure, while the slower air below has higher pressure, lifting the paper. This principle is used in airplane wings, race cars, and even chimneys to control airflow. So those are just examples of few examples of fluid mechanics. So the next one will be talking about the real life applications. So fluid mechanics is present everywhere around us. In hydraulic systems like brakes and lifts that use liquid pressure. In blood circulation as your heart pumps fluid through vessels. In weather systems,
where air currents and pressure changes create wind and storms, and even in water supply systems designed using fluid mechanics. Here are also several examples in fluid mechanics. In transportation, we have airplane flight, car aerodynamics, and ship buoyancy all depend on fluid mechanics. In medicine, we have blood flow in arteries, and IV fluid systems follow fluid dynamics. In engineering, we have designing dams, water pipes, and oil pipelines that requires understanding fluid pressures and flow. In weather forecasting, movements of air masses, wind, and storms are all governed by fluid mechanics. And even in our daily life or everyday life, we have shower, water pressure, perfume spray, and even drinking through a straw. It involves fluid mechanics. All of them includes fluid mechanics. So in simple terms, the examples of or the key principles of fluid dynamics is the first one, Pascal's law. Pressure applied to a fluid is transmitted equally in all directions. Example of this is the hydraulic brakes and hydraulic lifts. The next one is the buoyancy principle or the Archimedes principle. An object immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced. So an example of this is ship design, submarines, hot air balloons. And then the third one is the Bernoulli's principle. As the speed of a fluid increases, its pressure decreases. So an example of this is airplane wings, spray bottles, and carburetors. So to sum it up, fluid mechanics is everywhere. From the way airplanes fly, to how we pump water, to how our own hearts move blood through our bodies. Understanding how fluids behave helps engineers and scientists create solutions that make life easier, safer, and more efficient. So that's it. Thank you for listening, and we hope you have learned something from our discussion.
Good day, everyone. Today I'll be discussing thermodynamics, the study of how energy moves and changes from through heat and work. In simple terms, thermodynamics help us understand why hot coffee cools down, how engines run, and why an air conditioner makes things cold. It explains how energy is transferred between a system, which is the part we study, and its surrounding everything outside it. There are four main laws of thermodynamics, and I'll summarize them. First, the zeroth law. Tell us about thermal equilibrium. It says that if object A is in equilibrium with object B and B is in equilibrium with object C, then A and C are also in equilibrium. This is how we define temperature. Second, the first law of thermodynamics is the law of energy conservation. It states that energy cannot be created or destroyed, only transferred. In equation form, it's AU equals Q minus W, where this U is a change in internal energy, Q is heat added, and W is work done by the system. Third, the second law of thermodynamics introduces entropy, which is the measure of disorder. It tells us the heat naturally flows from a hot object to a cold one, not the other way around. This is why engines and machines can never be 100% efficient. Finally, the third law of thermodynamics states that as temperature approaches absolute zero, the entropy of a perfect crystal approaches zero as well. In simpler words, it's impossible to reach absolute zero. Thermodynamics is very important in our daily life. It applied in machine, power plant, refrigerator, and even in our body when we convert food into energy. To sum up, thermodynamics teaches us how energy works, changes, and flow, helping us understand and design systems that make life easier and more efficient.